in this problem, we're told that an urn contains red, green, and blue balls, and R, G, and B are the proportions of red, green, and blue balls respectively. So R plus G plus B equals 1. These are proportions of red, green, and blue balls respectively. So we're told in part A that the balls are drawn randomly with replacement. So drawn with replacement. And we want to find the probability that the first time a green ball is drawn is before the first time a blue ball is drawn. So we're going to make a few notations. So first let R sub I, this be the event that the ith draw is a red ball. So ith draw is a red ball. Then G sub I will be similar. Draw is a green ball. And B sub I, the event that the ith draw is a blue ball. And we'll also denote A, the event that a green ball is drawn before a blue ball. So we're interested in the event probability of A, P of A, and we're going to use the law of total probability to break this up in two cases. So in the first case, we're going to look at the scenario where the first ball is red, times the probability that green ball is drawn before a blue one, given that the first ball was red, plus the probability that the first ball is not red, times the probability that a green one is drawn before a blue one, given that the first ball is not red. Now the probability that the first ball is red is little r, because that's the proportion of red balls in the urn. And now, notice what happens. If we've picked a red ball, since we're sampling with replacement, we're going to put it back in the urn. And so it's as if we have not really sampled anything at all. It's as if we haven't even started the experiment, because we took out a red ball, we put it back in, the urn still contains the same balls as before, and we're going to essentially restart the experiment. So the probability that a green ball is drawn before a blue one, given that the first one was red, is the same as the unconditional probability of a green ball being drawn before a blue one. So plus, now the probability that the first ball was blue or green is G plus B. And the probability, and given that the first ball was blue or green, we want to know what's the probability that it was green, and that is G over G plus B. And this simplifies to R times probability of A plus G. And so, solving for probability of A, we get that probability of A equals G over G plus B. So now moving on to part B. Part B tells us that we're now drawing balls without replacement. So the balls are drawn without replacement. And again, we'd like to know the probability of A. So what's the probability that the first time a green ball is drawn is before the first time a blue ball is drawn? So one thing to note here is that we are going, so imagine drawing all of the balls from the urn. How many balls we have? Well, we have some number n times r plus n times g plus n times b balls in total. This is because the proportion of red balls was little r, and G was little g, and B was little, and blue balls was little b. So this is the total number of balls that we're going to draw. Now notice that the position of red balls is irrelevant for the problem. We don't care about the position of the red balls at all. So we could have red, red, green, blue, red, red, blue, blue, green, etc. Or we could have, let's say, we could have red, green, green, blue, red, red, green, blue. Now in this problem we only care about whether the first ball that was green or blue was green. We don't care about the red ones at all. So we can safely disregard the red balls in this sequence of draws, and we can say that the probability that the first time that the probability that a green ball is seen before a blue one is, we're just going to look at the sequence consisting of just green and blue balls, and suppose the first one is green, supposing the first ball is green, we now have NG plus NB minus 1 positions of balls to select from, and from these positions we need to pick the ones where the remaining NG minus 1 balls are going to go. So this is the number of sequences of draws of the green and blue balls such that the first one is green. And what is the total number of sequences of these green and blue balls? Well, that's NG plus NB, choose NG. So in total, we're going to select NG plus NB balls, that's the number of green and blue balls, and out of those we pick the positions, the NG positions, where the green balls are going to go. So that's the total number of ways to select a sequence of these green and blue balls, and we're interested in the number of ways to select such a sequence where the first ball is green. And so this probability, again, simplifies to G over G plus B, which matches the result from part A. So what this tells us is it doesn't matter whether we're sampling with replacement or without replacement. The fact still remains that we do not care about the red balls at all. We only care about the relative positions of the green and blue balls. We only care about whether out of the green and blue balls, the first one was green or not. Now part C of the problem asks us to generalize this result. So generalize the result from problem A. We're again sampling with replacement, so the balls are drawn with replacement. Now instead of 3 types of balls, instead of, let's say, red, green, and blue, we now have various types of balls. So let's say n types of balls, and we're gonna make a notation. So A sub I comma j is the event that ith type is drawn before the jth type. And notice that for this problem, again, all the remaining types of balls except for I and j are irrelevant. So as we draw these balls from the urn, we don't care about the positions of the other types of balls. All we care about is out of the type I and type j balls, what is the probability that the first one is an I type? And so generalizing the result from part A, we get that the probability equals P sub I over P sub I plus P sub j, where P sub k is the proportion of items of type k.